Today we are going to learn about mastering stress testing for microservices. This video will teach you how to design, execute, and analyze stress tests tailored for microservices environments to ensure reliability and scalability.
In this video, we will explore the world of microservices, an architectural style that structures an application as a collection of loosely coupled services. Each service in a microservices architecture is designed to handle a specific business capability, allowing for greater flexibility and scalability. One of the core characteristics of microservices is that they are independently deployable, which means teams can develop, test, and deploy each service separately. This architecture is particularly beneficial for large applications that require continuous deployment and scaling. However, microservices also introduce new challenges such as managing service dependencies, ensuring data consistency, and maintaining system stability under load. To address these challenges, stress testing is crucial as it helps identify the limits of your services, ensuring they remain reliable and scalable under high load conditions.
Stress testing is a critical component of ensuring the reliability of microservices. It involves testing an application under extreme load conditions to determine how it performs beyond normal operational capacity. The primary goal of stress testing in a microservices environment is to validate the system's stability and identify any potential bottlenecks that could degrade performance. By pushing the system to its limits, you can observe how different services respond to high loads and whether they can scale appropriately. This is particularly important in microservices, where each service may have its own unique load characteristics and scaling needs. Stress testing helps prepare your system for peak loads, ensuring that it can handle unexpected spikes in traffic without compromising user experience. Ultimately, effective stress testing contributes to a robust and resilient microservices architecture that can thrive in a dynamic and demanding environment.
Selecting the right tools and frameworks is essential for successful stress testing in a microservices environment. There are several popular tools available, each offering unique features that cater to different needs. Some of the widely used tools include Apache JMeter, Gatling, and Locust. When choosing a stress testing tool, consider factors such as ease of integration with existing C/CD pipelines, automation capabilities, and the ability to simulate realistic user scenarios. Automation is particularly important, as it allows you to run stress tests regularly and efficiently, ensuring your microservices are always ready for high loads. Additionally, look for tool-specific features that align with your testing objectives, such as support for various protocols, real-time analytics, and customizable dashboards. By leveraging the right tools, you can streamline your stress testing process and gain valuable insights into your microservices' performance under load.
Designing an effective stress test plan is a crucial step in mastering stress testing for microservices. The first step is to define clear testing objectives, which will guide the entire process. Your objectives may include identifying performance bottlenecks, verifying scalability, or assessing system behavior under peak load conditions. Next, identify the critical services within your microservices architecture that require testing. These are typically the services that are most essential to your application's functionality and are likely to experience the highest load. Once you've identified the critical services, determine the load levels you want to test. This involves understanding the expected peak loads and any potential traffic spikes your system may encounter. Creating realistic user scenarios is another important aspect of your test plan. These scenarios should mimic real-world usage patterns to provide accurate insights into your system's performance. Finally, establish success criteria that define what constitutes a successful stress test. This may include specific response time thresholds, error rates, or resource utilization metrics. By following these steps, you can design a comprehensive stress test plan that effectively evaluates your microservices' performance under stress. Executing stress tests effectively is critical to gaining meaningful insights into your microservices' performance. One key strategy is to gradually increase the load on your system rather than applying maximum stress from the start. This approach allows you to monitor how your system behaves as the load increases and helps identify the point at which performance begins to degrade. During the test, it's important to monitor system metrics such as CPU and memory usage, network latency, and error rates. These metrics provide valuable information about resource utilization and can help pinpoint areas that may require optimization. Additionally, it's essential to handle failures gracefully. Stress testing often reveals unexpected issues, so having a plan in place to mitigate these occurrences is crucial. An iterative testing approach is also beneficial, as it allows you to refine your tests based on the results and make necessary adjustments. By employing these execution strategies, you can conduct stress tests that accurately assess your microservices' ability to handle high loads. Once you've executed your stress tests, The next step is to analyze the results and identify any performance bottlenecks. Start by interpreting the test results to understand how your system performed under load. Look for patterns such as increased response times, higher error rates, or unexpected resource consumption. These patterns can indicate potential bottlenecks that need to be addressed. Correlating metrics with specific issues is crucial for pinpointing the root causes of performance problems. For example, if you notice high CPU usage during peak loads, it may indicate that a particular service requires optimization. Once you've identified the bottlenecks, prioritize the improvements based on their impact on system performance and user experience. It's important to focus on the changes that will have the most significant effect on your system's scalability and reliability. Finally, continuous monitoring is essential to ensure that your microservices remain optimized over time. By regularly analyzing performance metrics and making adjustments, you can maintain a resilient and high-performing microservices architecture. To ensure the scalability and reliability of your microservices, it's important to follow best practices in your design and testing processes. Begin by designing your microservices architecture with scalability in mind. This includes using stateless services, employing asynchronous communication, and ensuring that each service can scale independently. Implementing redundancy is another key practice that enhances reliability. By creating multiple instances of critical services, you can ensure that your system remains operational even if one instance fails. Optimizing resource usage is also essential for scalability. This involves fine-tuning your services to use resources efficiently, reducing waste, and maximizing performance. Leveraging auto-scaling capabilities can further enhance your system's ability to handle varying loads. Auto-scaling automatically adjusts the number of service instances based on demand, ensuring that your system can accommodate traffic spikes without manual intervention. Finally, embrace continuous testing as part of your development process. Regular stress testing and monitoring allow you to identify potential issues before they impact users, ensuring that your microservices remain robust and reliable over time.
In this case study, we will examine a real-world application of stress testing in a microservices environment. The project involved a large e-commerce platform that needed to ensure its microservices could handle high traffic during peak shopping periods. The platform faced several challenges, including unexpected traffic spikes, resource contention, and service interdependencies that affected performance. To address these challenges, the team implemented a comprehensive stress testing approach. They began by defining clear testing objectives and identifying the services most critical to the platform's functionality. Using tools like Apache JMeter, they created realistic user scenarios that mimic peak shopping behaviors. The stress tests revealed several bottlenecks, including slow response times in the checkout service and excessive CPU usage in the inventory management service. Based on these findings, the team optimized the affected services, improved resource allocation, and implemented auto-scaling features. The outcomes were significant, with the platform achieving a 30% improvement in response times and a 50% reduction in error rates during peak periods. This case study highlights the importance of stress testing in identifying and addressing performance issues in microservices, ultimately leading to a more scalable and reliable system.
As we wrap up this video on mastering stress testing for microservices, let's recap the key points we've covered. Stress testing is essential for ensuring the stability and scalability of microservices, allowing you to identify performance bottlenecks and prepare for peak loads. We've explored various tools and frameworks that can help you execute stress tests effectively, and we've discussed strategies for designing comprehensive test plans. Remember, continuous improvement is crucial in maintaining a reliable microservices architecture. Regular testing and monitoring enable you to adapt to changing demands and optimize your services for the best performance. We hope this video has provided you with valuable insights and practical knowledge to enhance the reliability of your microservices systems.